So here we are. We've already started talking a little bit about the scientific methods of psychology and how we conduct experiments and such. And so now I want to get into research methods. And sometimes this can be a little bit dry, but do understand that when you're looking at psychology, the only way you can back it up is if you have strong data and good research. So the methods that you use are going to be really important to give any credence or reliability, which is a word we'll talk about, to whatever you're doing, whether it's a survey or an experiment or whatever it happens to be. So it depends on kind of the research that you want to do. Are you looking to do experimental research? This is when research isolate the effects of variables on a group. Now, year after year after year, you've probably talked about dependent variables and independent variables, and we'll get into those in a bit. So an experiment is when you conduct an experiment. You usually have a group of people, one's a control group, one's an experimental group, and you're going to see how the whatever test you're running works on each of the groups. And so you are going to have these different variables. Right now in the room, you can see I'm here at school and not at home today. I have the fan blowing. There's quite a bit of sun outside. So could that impact the way I learn in this classroom? There's going to be many different variables of whatever your experiment tends to be. It specifies a cause and effect, if this, then that. And usually this is all developed, through that theory, that hypothesis that we talked about the other day. I wonder if, fill in the blank, I wonder if students get 10 hours of sleep if they get better grades in school. Well, how are you going to conduct that? If this, then that, a cause and effect. If they get more sleep, does it result in better grades at school? So there's going to be an independent variable that influences change in the dependent variable. So how I want you to look at this is look for the dependent variable. Look for this first. Researchers think that this is what's going to occur. They don't know, they just have this hypothesis, right? They're going to test a theory. So the dependent variable is the measured variable. And so ask yourself, whenever you're looking at any research, experiment, case study, whatever it happens, what is the researcher measuring or studying? Ask yourself that question first. What is the researcher trying to find out? And look for that first. Then once you realize the researcher is trying, let's go to the sleep experiment. The researcher is trying to find that if students sleep 10 hours a day, they're going to have better grades in school. So first they're going to have to look at their grades beforehand, then they're going to have to get the 10 hours of sleep, then they're going to look at their grades after. So what is a dependent variable here? They're trying to measure the grades. And so look for that one first. The independent variable is a factor that the research manipulates. This is what effect is being studied on the experimental group or the control group. So in the case of our sleep, we would monkey with, we'd mess around and manipulate those number of hours of sleep. If a student only got 7.5 hours of sleep, would that have any impact? If a student got 12.5 hours of sleep, would that have a different impact? So look for the independent variable second and ask yourself, what do researchers hope will cause the dependent variable? It's always easiest to look for the dependent variable because then the independent variable naturally kind of comes out. When you look for the dependent variable first, the independent variable becomes very easy to spot. So look for the dependent variable first, independent variable second. And so when you're doing an experiment, a study, collecting this data in a survey, whatever it happens to be, you're probably going to want a control group. A control group is that group that doesn't change. You know, you're messing around with one group. You got an experimental group here, but you're also going to want a control group to see, can I mess with these variables and this happens in the experimental group, and in the control group we're not letting any of those variables happen. So it's really important to do this for sampling and bias, and we're going to talk about that a lot. So there you see the cartoon. I don't like those little things, but the one group you can see here over on, they're like all freaking out and just high strung, and this group over here is just chilled and they're fine. And they said, well, I guess we're the control group. They're the ones who are not being, this is the group that's not being manipulated. They're not having anything done to them. This is the group that's, you know, lack of sleep or getting buzzed or whatever it happens to be. I mean, getting buzzed by like a buzzer, like that, never mind. You'll have a good laugh after that one. All right, so random sampling then. The importance of random sampling, let's go back to this cartoon for just a second. If we put these two in these two different cages, if you will, they have to be randomly put there. If we select, we're like, oh, well, we want these two in here and these two in here. That's not random. And then you get into the trouble of having a bias. So you want to equalize the two groups being studied. And the best way to probably do this is to have a double-blind experiment. And in the double-blind experiment, you're kind of taking away the bias that the experimenter naturally has. Like if you are the researcher, if you're the experimenter, you already are trying to test the hypothesis, right? You're actually trying to test that you're right. You have this theory, right? Well, you're trying to test it and you don't want to look dumb. And so you naturally have this bias because you want to prove it right. So the best way to conduct experiments is through a double-blind test. So you're going to have a control group and nothing's going to happen to them. They're not exposed to the treatment or whatever it happens to be, but you don't know that as the experimenter. Then there's another group that's having it done, that's being manipulated, but you don't know that either. So in a double blind, how do you make that happen? You actually have one more researcher who's administering the experiment. And the overall experimenter would be basically saying, okay, I want this done in order for this, you know, to see what happens, the effect of this. But you're not actually the one applying that experimentation. Because if you are, you're going to naturally have some bias. So if you can have somebody else kind of directing it and one person performing the experiment, then you have a really strong experiment. Then you know you're taking out bias, you've got a good sample size, you have good control groups, and it's going to be reliable and it's going to be a valid study or experiment. So I had to put this on. This is the placebo. Sometimes the placebo effect is a really strong effect. The placebo effect is when you, you know, I don't know, do you have like little brothers or sisters, or do any of you babysit maybe? What I see in the, like a placebo, let me give you an instance. You're babysitting your 4-year-old cousin, and they slip and fall and, you know, get like the tiniest little, like, you can't even see it. Like there's nothing even wrong with their knee, but they are wailing and carrying on like it's the worst thing ever. And maybe you like, you know, rub it and it's still not making them happy. And they're like, and you say, should we put a Band-Aid on it? And then all of a sudden they're like, yeah, that would make it feel better. And magically, like this Band-Aid makes it feel better. Well, this is kind of the same idea with the placebo. In a placebo, you think you might be receiving the treatment, but you don't actually know. And so actually in your mind, you are receiving the treatment. But if you feel like you're doing, is it the thought of receiving, let's say a medication? Let's do a medication, because that's probably one of the most easy examples that we can use in experiments. Let's say you're one of those trials, in a trial for an experimental drug, and you are receiving the actual drug, and it's working the way they hoped it would work. But what if you are in the placebo group and it's working the way they hoped it would work, but you're actually getting a sugar pill? Well, then the experimenter has to say, okay, so something's going on with our control group here, and they are actually getting a placebo, thinking it's the regular medication, and they're doing pretty well, so maybe this medication is not actually what we're hoping it would be. Because if the experimental group is feeling great, and the control group is feeling great, and the control group is only getting the placebo, we got a problem. You see what I'm saying here? So a placebo is a really powerful tool to see how good the experiment is, really the manipulation is. All right, I think that's all I want. Oh, yeah, there's my cartoon. If I don't think it's gonna work, will it still work? So the doctor's giving him a prescription, and the doctor's saying, all right, take this 3 times a week and for your high blood pressure, whatever, fill in the blank. And the man says, well, if I don't think it's going to work, will it still work? Is this a mind over matter? Is this something that, you just think it's a bunch of baloney and you've tried everything and this is just one more pill that the doctor's going to see if it works because they're just practicing medicine on you? Is it still going to work? And so sometimes this can be a matter of mental willpower. Not always, but sometimes. All right, so descriptive studies. This says case studies focus on a small group or individual. So a case study is just that. It's a smaller group. Sometimes you can't do experiments on a huge sample of people. Like you can't carry that out. So maybe you focus on 5 people because that's more manageable. That's called a descriptive study. And it's obtained through naturalistic observation, and that just means exactly what I say. You're watching them in their natural environment. Again, this works for a case study because there's only, let's say, 5 people. If you have a huge experiment going on and you're, testing 1,000 subjects, you can't watch 1,000 subjects in their natural environment, in their natural, wherever they live, their day-to-day life. But you could maybe do it in a case study with 2, 3, 5 people. It could happen. Or direct observation. And direct observation is when you are being watched. Now, when people know they're being watched, it's kind of like if you are a really great, you're really outstanding athlete, and you hear your coach tells you, yeah, so there's gonna be a scout at the game tonight. Now you're being watched. Like, you're always being watched, but now, like, it's maybe now somebody's measuring. Now somebody's like writing stuff down. That's more direct observation. So really what we're looking here is to kind of come up with a universal truth. What they're going to do in a case study is look at, let's say these 5 subjects, and they're going to try to apply what's happened in this case study with, say, these 5 subjects to the body of people, the masses of people. Now, it may be true, but it may not be. That's where it's good to look at a few case studies and see, okay, are they all finding the same types of things? Are they looking for the same types of things? What are their variables? What are their restraints? What are their control groups and things like that? So like in descriptive studies, they might not have a control group. They won't have a control group, actually. And so then what do you compare it to? And so they're making kind of a universal generalization that sometimes is helpful and sometimes is just too general. So case studies are great, but they can only take us so far. Single cases might be misleading and not show the true cause and effect, as I just mentioned. All right, correlational studies detects how well one variable predicts another. So a correlation, you know what a correlation means, like how well this is going to predict this happening, the cause and effect type situation. So surveys are good. A type of self-reporting that can look at many cases at once. A survey can be verbal, it can be written. However, the downfall that you're going to see right away in a survey is that word self-reporting. People are going to say or write whatever they want. They don't necessarily have to be honest. They're not being watched when they do it. They're not being observed by somebody in a lab setting. And so correlational studies are great because you can do them on bigger groups, like surveys. You can do a huge survey out to the population, or a sample size, a big sample size. But then you have to rely on people being honest and upfront. So if you're going to do a survey, those are great. They work. They should be, in fact, they must be random, by chance. It means the people that you want this survey to go to, it can't be only this, who you have in mind. It has to be completely random or by chance. It needs to be a good representative sample, means the characteristics match. What I mean by that is what are you trying to measure, and who should it be going to by chance? Let's say we want to measure, let's just go back to the sleeping in students. I have a hypothesis that if students sleep at least 10 hours a day, they get better grades in school. So I would, send out a survey and ask students like how much they sleep, and again, they could lie. I would ask them like how many hours they look at their phone before bed. I can ask them all these questions. And I'd send this out to students, right? But should I send it to high school students? Should I send it to college students? What about elementary school students? What if I'd send it out to parents and they'd answer it? Like, those are the kind of characteristics that you need to make sure they're good. Are we getting good differences in boys and girls? Are we getting, 14 to 18-year-olds? Are we getting in this, region, or whatever it happens to be? All right. And so they should be based on the population. And the population is not like not the entire population of Fargo or like North Dakota or whatever. It should be based on all the participants who could potentially be in that group to be studied. You could have millions upon millions of 14 to 18-year-olds in the United States, but that's a big population. I only want a representative sample of a few who are randomly chosen to be put in there. I hope that makes sense. And if it doesn't, please jot some notes so we can talk about this tomorrow. So when we're looking at a correlation, the strength of the correlation is going to be measured from 1 to -1. Now, I'm going to say this over and over and over again. +1 to -1. And positive and negative are the terms that we use in psychology that does not mean good or bad. It means closer to or further away. So, closer to it being true or further away from it being true. It doesn't mean it's good, like yay, thumbs up, or bad, thumbs down. It means it's more correlated together or it's further apart. So correlated, you have a perfect correlation, means it's 100% right there, everything's lining up. Or as you get further out, think of it like a linear, like on a line, from a -1 to a +1, and 0 is right in the middle. If it's a 0, well, that means what? There's no correlation, right? There's no rhyme or reason as to why this happened. A +1 or a +1 means there's strong correlation. A -1 still means there's strong correlation, but in a different way. So one other thing, Correlation does not mean causation. I'm going to say it over and over and over again. Correlation does not mean causation. Just because something is highly, strongly correlated does not mean that that caused it. So for instance, let's go back to the sleep. Just because you got 10 hours of sleep and you got straight A's does not mean that that sleep got you the straight A's. Because I can absolutely tell you, there are students who get straight A's and don't get 10 hours of sleep. Now, am I going to try to say there are more students who get A's who sleep more? Sure, that's my hypothesis. But correlation does not mean causation. Just because you get 10 hours of sleep does not mean that you're going to get straight A's. Okay? So here's a perfect positive correlation. So here's the independent variable along the x-axis, the dependent variable along the y-axis, and you can see it's perfectly in line. This is a perfect positive correlation, a +1, if you will. This is a perfect negative correlation. Here's the x-axis, here's the y-axis. You can see it's perfectly a negative correlation, a -1. Now, negative does not mean bad. It does not mean a bad correlation. It does not mean that. It means closer to or further away. There's no correlation. There's no rhyme or reason as to where these variables lined up. If this, then that, like, there's no rhyme or reason. So there's no correlation. That's 0. If, again, we think of it on a line from +1 to -1, and 0 is right in the middle, this is nothing. It's just, there's just scattered dots. It's just a scatter plot. Okay, so this is the last thing I'm going to go through. So look at this one. I have some examples here. This first one. The more income rose among a sample of poor families, the fewer psychiatric symptoms in the children were experienced. So is that going to be the one on the left, the one in the middle, or the one on the right? The more income rose, the fewer, in a sample of poor families, the fewer psychological or psychiatric symptoms the children experience. So as one goes up, the other goes down. As income rose, fewer symptoms were experienced. This is going to be a negative correlation. I hope you said it with me. As one goes up, the other goes down. That's going to be this one here on the left. As income rose, psychiatric symptoms went down. What about this correlation? The longer children were breastfed, the greater their later academic achievement. So the longer the children were breastfed, the greater their academic achievement. As one goes up, the other goes up. So I hope you're saying with me, this is a positive correlation because both are trending upward. That's this one on the right. This one, there's no correlation here. There's nothing here. So remember, as one goes up and the other goes up, that's positive correlation. If one variable goes up and one variable goes down, that's a negative correlation. I could give you tons of examples, but remember, correlation is just measuring the strength of which two things relate. +1 to a -1. How do those two things relate? All right, so we're going to stop there for the day, and we'll finish up with this and talk about reliability and validity some more. Have a good one. Bye.